We are recording. Please stand. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Credo in Deum, Patrem omnipotentem, Creatorem caeli et terra, et in Iesum Christum, Filium eius unicum, Dominum nostrum, qui conceptus est de Spiritus Sancto, natus ex Maria Virgine, passus sub Pontio Pilato, crucifixus, mortuus, sepultus, descendit ad infernos, tertia die resurrexit a mortuis, ascendit ad caelus, sedet ad dexteram Dei Patris omnipotentis, inde venturus est judicare vivos et mortuos. Credo in Spiritum Sanctum, Sanctam Ecclesiam Catholicam, Sanctorum Communionem, remissionem peccatorum, caritas resurrectionem, vitam aeternam. Amen. In nomine Patris et Filii et Spiritus Sancti. Have you seen that before? Okay. All righty. Refresh my memory. What was the name of the worksheet we had checked out? It was 2B/2. Okay. Let's see what you have. I'll come around the back this time just to the right. And I better have one little left.
It's always nerve wracking. That's great.
All right. 2B-2.
Every time.
All right, it says state the number of complex roots, which just means the number of total roots. Then the possible rational roots, that's the factors the last over the factors the first. Actually, let me pull this in. I just realized people watching at home, I was going to hear this disembodied voice coming from off screen. So, hi, I'm here. So, state the number of complex roots, which is how many total roots. Then list all the possible rational roots. You can leave it in that compact form. Give me an interval in which all the roots lie, and then factor and solve. So let's see what we got. Number 1, the number of roots is 3. The possible rational roots is plus or minus 1 over plus or minus 1 and 2. Is that gonna make sense? It'll look like this. That's all you really need to write. You do not have to list them out individually, although if you did, bravo. This is pretty much 4 numbers. 1 over 1, 1 over 2, negative 1 over 1, negative 1 over 2. Okay. The real roots lie in between negative 1 and 1. Then factor and solve. There are 3 solutions. It should be x equals 2. Oh, sorry, my bad. Sorry, x equals 1, another x equals 1, and x equals negative 1/2. You didn't absolutely have to write the x equals 1 twice, although if you did, that's fine. And then a factor is 2, excuse me, 2 parentheses x minus 1, x minus 1, x plus 1/2. Any repeats on that? That was kind of a mouthful. Alrighty, number 2. The number of roots is 3. The complex roots should look like this. Plus or minus 1 and 6, 2 and 3. You can put them in order if you want. Factors of the last over the factors of the first, which have been 1 and 5. And again, you can just leave it like that. Those are all the possible rational roots. All the roots lie between negative 6 and 6. The solutions, there's only one rational root, x equals 2/5. The other ones are, if you could have solved it with the quadratic formula, but you should see a bunch of i's showing up. I'll give them to you anyway, because I think I had you, well, that was the one, the factor by grouping. Should be x equals 2/5, x equals I radical 3, and x equals negative I radical 3. It factors to this. 5, parentheses, x minus 2/5, and then basically x squared plus 3. Should factor down to that. And repeats on that. And we'll go through any of these you want. Number 3. Number of total roots is 3. The possible rational roots, it's kind of a long one this time. I write them in pairs because it's easier to do. 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8. I think that's it. All over, plus or minus 1. All the roots lie between negative 40 and 40. Factors, you should get x plus 5. And then, hang on a second. Oh, that's interesting. I think it's x squared. Hang on a second. X squared plus. That's really random. I might have to do that by hand. They simplified it, which I didn't want them to do. Let me just do this by hand. X cubed, minus, this is probably in the way, right? Minus 3x squared, minus 48x, minus 40. And guessing around, you can find that negative 5 is one of the roots. So I'm going to do synthetic division here. Add, multiply, add, multiply, add, multiply, add. So this thing here is 1x squared plus negative 8x plus negative 8. So to factor this thing, you'll have x plus 5, x squared minus 8x, oops, minus 8. So that's the factoring part. For solving, I would take the quadratic formula on this thing. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So this turns into 8 plus or minus the square root of 64 plus 32 all over 2, which is 8 plus or minus, this is 96. That does simplify a bit. This 16 times 6, radical 16, radical 6, over 2, which is 8 plus or minus 4 radical 6 over 2. And I'm going to split that up. 8 over 2 plus or minus 4 radical 6 over 2, which eventually becomes 4 plus or minus 2 radical 6. So if x equals 4 plus 2 radical 6, and x equals 4 minus 2 radical 6. And then the third one was x equals negative 5. That's for number 3. And number 4, number of roots is 3. The possible rational roots looks like this. Plus or minus 1 and 9, and also 3. It doesn't matter if you do 3 twice. And then all over plus or minus 1 and 2. So there's the rational roots for number 4. All the real roots lie between negative 9 and 9. It factors to 2 parentheses x minus 3 halves. And then, let me take a look, x squared plus 3. The roots you'll get are x equals 3 over 2, x equals I radical 3, x equals negative I radical 3. Any repeats? All right, I'm bracing myself. Hit me with it. Go for it. What would you like to see dissected? Number two. Let's try it. We've got 5x cubed. Somebody can the stuff on the board? How many still writing? Need to wipe this stuff out. So number two looks like this. 5x cubed. Right, Mark. Excuse me. 5x cubed minus 2x squared plus 15x minus 6 equals 0. And the opposites, this factors by grouping. So we don't have to start guessing. This is going to be x squared, parentheses 5x minus 2 plus negative 2. And this one pulls out a 3, and this is 5x plus negative 2 equals 0. So pull this out in front. I'll do 5x minus 2 for old time's sake. This is x squared plus 3 equals 0. Did anybody have this as a factory without the 5 in front? I'll accept that. That's okay. Basically, you take the 5 in my answer and distribute it in to the x minus 2/5. And you'll get this. This is fine. So now set these both equal to 0. And then this is 5x minus 2 equals 0. X squared plus 3 equals 0. This is not going to be real numbers. Let's try this one first because they're real. So 5x equals 2 divided by 5. X equals 2/5. And the other one, x squared equals negative 3. So x equals plus or minus the square root of negative 3, which is really radical 3 times radical negative 1. So x equals plus or minus radical 3 times I. Or you could put I radical 3. And those are your three roots. Does anybody want to see anything else covered on that? I mean, that was how to solve. But how to factor, you got it here. Rational root theorem, factors of the last over factors of the first. The number of roots is just the degree. Hopefully that's okay. Any questions on that one? Next. Yeah.
Actually, for number one, I was wondering how you got one as an answer twice.
Oh, interesting question. How to get number one as an answer twice? Let me write it. 2x cubed plus 3x squared. Oh, wrong. Why am I carrying around this marker when it's useless? Actually, if it's semi-useless, I'll just put it over here, put it to the side. There is a shelf. Okay. 5x cubed. This is number one. 5x cubed minus, what am I doing? 2x cubed, sorry. 2x cubed minus 3x squared plus 1 equals 0. Now, in order to do this, it doesn't factor by any known method, so I have to start guessing. Can anybody tell me the one thing I have to do in order to set it up for synthetic division? There's something not quite right. Anybody see it? Yeah. It's missing a regular x term. So we're doing 2x cubed plus negative 3x squared plus 0x plus 1. So you have to do that. In order to do long division or synthetic division, all the terms have to be there, even if they're blank, even if there's 0. So I just start guessing. And by the way, the list of possible rational roots is meant to help you. It's not meant to be an extra tedious thing. It's supposed to give you a list of things to try. So this is 1, negative 1, 1/2, negative 1/2. And if none of those four work, you're off the hook for the problem. You do not have to go guessing at irrational or imaginary roots. I'm going to try 1 first just because it's nice and easy. So add, multiply, add, multiply, add, multiply, add. Ding, 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 ding. It worked. This thing is really 2x squared plus negative 1x plus negative 1. I know that x equals 1 as a solution. This thing is now small enough to factor or use quadratic formula. Preference? Who asked about that? This was Chad, you were right. Do you prefer quadratic formula or factoring, or it's up to you?
Quadratic formula's fine.
Quadratic formula, let's do it. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So I'm going to get x equals 1 plus or minus the square root of 1 plus 8 all over 4. This is the square root of 9 really, which is 3. X equals 1 plus or minus 3 over 4. So you're going to get two solutions. X equals 4 over 4, which is another 1. And then x equals negative 2 over 4, which is negative 1 half. So there you get three roots. X equals 1, x equals 1, and x equals negative 1 half. So what happened if you, like, if you graph this thing, you've got a root at 1 and a root at 1 half. There's a negative 1 half, Michael. There's a single root at negative 1 half, and there's a double root at 1. And since this is a cubic, positive cubic, so it goes up, down, up. It's positive because the first number is positive. And it's a cubic, it just goes up, down, up. It's going to punch through and then bounce. So if you had to make a rough graph, it would look like that. Did it make sense? So how did I know there was a duplicate root? I didn't, until I stumbled upon the second one down here. Next. There are only two more, but all of them are fair game. Go ahead. You can make me work. I saying y'all, are y'all tired or y'all just comfy with us? Okay. Is everybody feeling okay? If I put this on the test, you can do it? Okay, I'm just seeing some interesting facial expressions. If you are in doubt about any of these, ask them. Otherwise, I'll assume that it's green light. Yeah.
Can you do another problem like these?
Another problem like this? Yes, although it'll be in tonight's homework. So, questions? All right, go ahead and put that away. Take out your notes, please. We are looking at possibly a book assignment. We'll see. Been threatening to do 2F for a long time. I think that is what's going to happen. Solving by factoring. Starts on page 80, the reading. Yes. That's looking pretty good. Let me manufacture a new one for you. And this, Josh, this will be an answer to your question. Tell you what, I'll let you choose. The degree has to be above 3. I don't really care beyond that. I'm gonna choose, I wouldn't go as high as 7 because that'll take forever. So 4, 5, or 6. What do you think? 6. Brave. Brave. First come, first serve. Let's try this. Presto changeo. Here you go. Wow. Yeah, I'll do it. try the following. Solve, let's say factor and solve. And then list number of roots, possible rational roots, the interval containing the roots, and was that? Yeah, stick with that. So it is as follows: 11x to the fifth minus x to the fourth minus 77x to the third plus 7x squared plus 132x minus 12 equals 0. Go ahead and write that down first. First of all, can somebody tell me the number of roots? Yeah. 5. How do you know? The highest exponent. The degree of the polynomial, the highest exponent is 5. So that's how many roots it has to have. What are the possible RAT apostrophe L is abbreviated for rational? Can somebody list me the possible rational roots? You can leave it in the compact fraction. You don't have to list them all off separately. You can just do the plus minus over plus minus and leave it. Somebody feeling courageous on that point? Go. Plus minus. 6. Okay. I usually do them in order. You can do them in any order you want, but usually I start with 1 and then do them in pairs. Why? Because I have a tendency to miss things if I don't do them in order. So what do you think? 1 and 1 times 12. 2 times 6. 3 and 4. And then when 4 is already there, so you know you're done. Over what? 1 and 11. And that's it. Okay, because it's prime. Is everybody good so far? What is the interval containing the roots? Megan. X has to be on the interval from 1 to what? What's that? From negative 12 to 12. Correct. We went through interval notation, right? Square bracket, round bracket. That was like chapter 1. Did we get that? All right. We put off the inevitable. I'm going to put a 1 here and add the opposite, add the opposite, add the opposite. What would you suggest? Any ideas? Yeah. Can it be factored by grouping? You tell me. How would you tell? And in 6 terms, there are actually 2 ways you can factor by grouping. No guarantee either will work, just saying. But you could do triplet, triplet, or you could do 3 pairs of 2. It doesn't matter what groups, as long as the groups work. What do you think? Interesting idea. If you don't want to try factor by grouping, you can just start guessing, and then use this list. So basically, 1 is a possibility, negative 1 is a possibility, 2, 3, 4, 6, 12, and negative. And then a bunch of fractions of 1 over 11, 2 over 11, 3 over 11. Yeah. 1 factor by grouping. All right, how so?
32.
Okay. And then, I'm sorry, what?
Pairs of 2.
Pairs of 2, okay. I know what you mean. Pairs are 2, but it just occurred to me. I do that all the time. I got a dozen of 12 here. I said that a couple of years ago and I was getting eggs. Does this, what comes out of here?
You do 1.
1 and what's the little mini
One
GC?
x to the fourth.
X to the fourth, correct. Now what's left behind?
11x plus negative 1.
Good, 11x plus negative 1. Take over, Katie. What comes out of here? What's the mini GCF, if you will? Close. There's one teeny thing missing. Negative 7x squared. Yeah, if it starts negative, it's negative. So negative 7x squared, and then what's left behind? Negative 1, good, because the x is up. Plus, next, take over. What's the mini GCF here? Is that one?
No, no, it doesn't.
Interestingly enough, it actually does. No x is correct. There's no x you can pull out.
What times what equals 132?
Good question. Good thing. 12. And then what comes out? What's left behind? Yeah, 11x plus negative 1. 12 times 11 is 132. Is this going to work? Okay. Yes. Why do you say that? All the parentheses are the same. That means that's a common factor. Pull that out in front. It's weird to see a triple common factor, but 11x plus negative 1 comes in front. And then what's the leftovers while you're at it? Good. Plus 12 equals 0. Any bright ideas for the rest of it? It's a good practice problem. I'm a little disappointed that I made it factorable at all, but okay. We're being denied the pleasure of guessing. But, very quick. Say again, sorry? Yeah, this one does factor. How? I'm going to write this as 11x minus 1. I have no idea why. You can unfoil it. It looks like it's x to the fourth, and you figure, well, fourth is too big for unfoil, but it kind of has the same structure as unfoil. What would x to the fourth split into? Right, x squared, x squared. So if it has the same form as an unfoil problem, maybe it does work. You can think of two numbers and add up to negative 7 and multiply by 12. Correct. Do either of those factor? Make it. Sorry, glaring through the tower of power there. Is it? Do either of those factor? Okay. We have x squared minus 4 and x squared minus 3. Yeah, what does that factor into? Yep. And what? What method are you using? There's GCF, unfoil, binomial squared, difference of two squares, grouping, magic pair, substitution. Which one? X squared minus 4. Let me see. Difference of two squares. It's a square minus a square. So it's x minus 2 and then, remember? Okay, okay. X plus 2, right. Difference of two squares falls into x plus something, x minus something. And then, does anybody see this? It's a little harder to see. Does that factor? Last year I would have said no. This year, since we are like super tough pre-calc military forces, I'd say it might. It's difference of two squares, believe it or not. X and x, plus minus what? Something unusual. 2. How did we get 2 here, by the way? Like if you were x
Take the
squared,
square root.
take the square root. Interesting. What do you put here?
Square root three.
Ding, 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 ding. By the way, I was not counting on people to know that. You could have just set this parentheses equal to 0 and it would have worked just as well. We're eventually going to do the zero product property. If you factor this bottom, and this is actually a tricky one to factor, you can see the roots right away, but you don't have to. You could have just set these equal to 0 and it would have worked fine. So, can somebody tell me the roots now? From beginning to end. Right there, give me one. Yeah, set this equal to 0. 11x minus 1 equals 0, so 11x equals 1. X equals 1 over 11. Nice. Give me the next one while you're at it. And one more. X equals negative 2. Josh, give me the last two.
X equals
Negative radical 3?
X equals
Positive radical 3. So you have solved and you have factored. And you're done. Does that make sense? Nice. Believe it or not, I think we're done. So your assignment, if you take a look on your homework guide sheet, it is, just so everybody's aware, we're skipping to 2F as in Franklin. Can somebody please tell me what this means on the homework guide sheet? Translate that into English. Yeah. 4 through 44, multiples of 4. Yes. I told you a story about my first job I ever taught where somebody did 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 44, and did them all again, and then did them all again, and then did them all again 4 times. That's what they thought it meant. I felt kind of bad. I also felt like, didn't you feel a little suspicious after doing the exact same problem twice? It means 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. So there should be 11 problems. And I think you have the rest of the hour to go ahead and pound away at those. You may work in groups, you may work individually if you like. Somebody got my finger here, I'm just about to turn this off, so people at home, this is my hand waving goodbye. Talk to you later. Is that good? Kinda? A little further in?
Yeah.